Alright, I think we're live. Hey everyone, I'm David Room. Today we're going to be using Python code to do a layout of a sci-fi scene in Blender using my custom Python Blender 3D mesh processing library. And I'll kind of talk you through what we're going to do here. First, I just want to make sure that I've shared that I'm live on Twitter so people from Twitter can hop on if they want to. So I've been working the past couple weeks. I'm on paternity leave and at the beach. I've been working on a project to kind of start several different 3D art pieces using my tools, and at least kind of get them to a sort of an initial state where they're easy to work on. And I got sort of started doing the layout of this one, and this is kind of a screenshot of what the Blender window looked like in my manually updated layout. So programmatically, where this is I can run a script, I can get these ships in the scene, but there's a few lighting things as well as the ship positions and the camera positions that I haven't added in yet. So what we're going to do today is I have this saved as a Blender project. We're going to open it up, and then we're going to copy some of the locations of these things, configurations or whatever, into my script, get it working programmatically, and then run it and kind of tweak it. And then if we can get through that, there's a couple of 3D modeling related tasks that I want to do. There's a few different things we could do. We could work on getting more materials on this big ship. You can see these smaller ships have kind of a full set of materials. I haven't done that for this big ship yet. I'm still kind of doing some modeling on the big ship, so I'm not maybe ready to do that quite yet. But there is some additional modeling of details that I want to do on the big ship, so we could work on that too. But let's just start with getting this scene layout done. I'll open the actual blend file. I'm going to get some music going here. We're going to go back to our original dark synth soundtrack from White Bat. So I haven't listened to this for a while. I've been using some other ones, but we'll go back to this one and see how it is. Okay, so yeah, let's bring up the Blender file. So I kind of like to save my manual experimentation in sort of checkpoints, but I want to do, 95 to 99% of what I'm doing with this art actually in Python. So, okay, so let's take a look here. Unfortunately, I had this really nice subtle view or subtle color that I sort of lost when I saved it at one point. I'm gonna actually I just maybe desaturated this, I think. Yeah, that's probably what happened. And I'm just gonna tweak a couple of render settings here so we're being a little bit more efficient with our rendering. Okay. Let's make sure everything's going here. Okay, so I'm gonna tweak some render settings first, just so I've actually updated some of this stuff, which you'll see when I start iterating on the programmatic version. I kind of figured out some good settings here for this stuff. That will happen automatically now, but I didn't have it at this point when I was making this file. So this looks kind of like I want it to, should be pretty efficient to work. Oh, I've got to do this. Performance 2x. Okay. All right. So we have our 4 ships, and we're going to start by copying those positions over. And I'd like to round these off a little bit, just so I have nice numbers, but I really like how this scene looks, so I might just kind of copy them directly. So here's my function that builds the ship positions. I think the Blender view is a little bit more interesting, so I'll probably put the code view off screen and I'll just do the copying. And I think at some point I need to figure out how to activate the Blender keys again so you can see what I'm pressing, but there's actually a way you can copy, I think it's like with Control-Alt-C, you can copy a whole, you can copy like a whole vector. So looks like this. And I'll just paste these other ones in off screen. We don't have any rotations on any of this stuff, it's just flat. Where the rotation is going to come in is for the camera. So that gets the positions of the ships. Now let's see here. Our camera. Oh yeah, we have this cam parent thing. Yeah, so this is actually, we'll have to implement this here. So we need to create an object for the camera to be parented to. Let's see, where am I actually doing cam target? Let's see, do I have another example of this in my code? It seems like it. Maybe not. Okay, so we're gonna have cam parent. And the reason we're doing this is because we want to use a constraint to point the camera, but we also want to give it some rotation separate from that. I haven't been able to figure out how to do that with just the constraint, so we're going to do it just by parenting the camera to something else. And I might not have the capability to get cameras parented in here, but we should be able to figure out how to do that. I've got enough hacky ways to patch that kind of stuff in, and it's kind of be interesting to do that, try to do that on the fly here. Okay. Okay. But at any rate, the kind of annoying part here is just copying these values once you have them laid out, so we'll get that done. And that camera, I think we could call it roll, is 30 degrees. Okay, and the other thing that we have here is we have the sun, And then I have a second sunlight, and I'm not sure if a sunlight is really the right way to do this. But I have a second light for this kind of bottom illumination. Let's just get the sunlight in for now, and then we can kind of start comparing. And there's not really any reason to have a particular transformation on the sun other than just kind of where it is in the layout, so it doesn't actually matter. And then for the rotation, we have to kind of bring this over piece by piece, because this is so we have a X, Y, and Z rotation, and the way the rotations work in my interface is they're HPR, so a heading, pitch, and roll. So we just got to think which one corresponds to which. So Z is heading, pitch is going to be X, and roll is Y. So we want 0, I think we want 0, 10, 10. We should be able to see right away if this is right or not. Okay, so now let's see here. Yeah, see, I have this sort of special way of doing the tracking constraint. I don't know if I can do that parent 2 with the camera, but I can add it in. That would be a good thing to try to do here. So let's rotation. Oh yeah, and that's the other thing. So I have rotation. I can't do. Okay. We might have to do this with a config update, which the days are blending together. I'm trying to remember. See how I did the stars, because I did the stars. Yeah. Okay. Let's update. Let's add a couple things here to config update and how we handle it. So yeah, because we're getting an object by name, and then let's see here. What is it called here? The oh, is it just props? Yeah. Okay, so this should actually work. Yeah, okay. So I should be able to just add properties to my config update and get that other stuff in there. So let's do a config, and I think the camera goes in first in here. So this is my script that I use to create a Blender scene. So yeah, the camera goes in first and then the model. So basically we can throw that update in on everything. So we'll just do a cam update spt.config update. So we'll be updating we'll actually be updating camera. And yeah, so we'll be updating camera with the property of a child of which is going to look something like this. So these are just, you can kind of think of these just like commands that are going to tell Blender to sort of do an operation. So this will be cam parent. And then I should actually be able to put a new transformation in here too, I think. So the translation is going to be actually, I'll implement this and then we'll comment out and see if it works. So translation equals just 0. And the rotation is going to be 30 on our Y for that roll. Actually, constant camera. Roll. Okay. And I'm curious to see if this works. I think this is actually going to be the first time that I've used, or one of the only times that I've used config update. Yeah. Cool. So we'll just take the camera. Updates. Oh, this should be. So this is actually going to be that. Okay. Got this stuff set up. Let me just set the cycles config dot preview samples to 32, and I don't think I messed with the sun's strength. So all right, so here was our example. And this actually also probably has like a lot of extra, might have some extra geometry and stuff in it too. So that'll be interesting to compare. When we rerun this, will it kind of run more efficiently than the original? Okay. Let's run it and find out. Okay. That's an easy one. Somewhere init var. Oh, that's interesting, actually. Failed to dump value. Oh. Let's see, config app. Update. So. DC. That's interesting. I wonder if I did this correctly. Let me just... So, having trouble dumping this, and that kind of says to me I didn't implement this... excuse me, that I didn't implement this init var thing correctly. So this is like an initialization of a default value so that you don't end up like reusing a mutable variable. But it could be that I just never used this, so I don't know actually how it works. Let's see, just looking here. Init var, describe variables that are init only. Pseudo fields. Oh, okay. Let's see here. I think I'm not using it correctly. Init var default list. Let's see what the little Google AI has to say about it. Init var. Oh, okay. So I still got to use... Yeah, I got to use this default factory thing. That's funny. Default factory. Did I never use that? Okay. Strange. And I don't want this to be actually init var. That's just wrong. Okay, so let's fix this. It's just gonna be DC fields default factory. Okay, init var. DC field init. Whoops. Field default factory is list. That's strange. Okay. I normally try to stay away from stuff like that, but update. Oh, okay. And this is the default material initialization, which we don't want for config update. Yeah, wow, this is interesting. I implemented this config update thing several days ago and never really used it. So we'll see. Oof. Something. see what happened. We have 2 cam targets. Cam parent. I think I just forgot to rename it. Cam parent. Yeah. Okay, and I'm gonna disable the real stars for a second, so we can iterate on this a little faster. Okay, cool. That's right, it's just upside down, and I think that's because we have a different kind of constraint here. Let's take a look at our reference here. Oh, okay, so I need to put this damped track on cam parent instead. And that actually is just going to be a track 2, not a damped track. So... okay. Okay, so now actually we can just actually put the rotation back here. So 0 const.cam roll and 0. We'll leave it both places. We might be able to get rid of it. And what would be really nice is if point at. It'd be really nice if this was just. See, I think I made this before I had the ability to do a lot of these like modifiers and things. So it'd be nice if this was just its own thing rather than. Okay, yeah, we can do this through as a property. Rather than this rotation thing. So let's do that. So instead of doing this here, we'll do this as a property. Blender equals this. Let's see here. Stuff. So, let's see. We need to do a track 2. It's constraint type, track axis, up axis, and our destination is going to be cam target. Yeah. Now, let me just check one thing quick. So when we do a config update, how is that going to handle the transformation? If transformation is not none, it'll apply it, so we can actually just get rid of we should be able to get rid of the transformation field in this update. Okay. That was not too painful. So let's see if it works. And we just have our original Blender window still open here. Uh-oh. Okay, so the scene looks right. We have our camera, but I don't think child of cam parent. Let's see here. Camera. It's child of cam parent. Oh, I need to turn the rotation on this guy. That's what it is. That's what it is. So we need to add the ability to turn the rotation on. Let's just double check and see if that's actually what's going on here. And boop, boop, boop. Alright, that's not it. Child of cam parent. Okay, what else is going on here? Cam parent. I'm just comparing. Oh, okay, it's cam parent that's got the track 2. Cam parent props. Blender. Test cam target. Okay. This should have been applied. This isn't like a crazy update or anything weird. So why didn't that get applied? Let's property track 2 not allowed for empty. Why would that not be allowed for empty? Empty. That data is none. Alright, that's strange. I don't know why I added that logic in before. Okay. Let's get that capability to turn rotation on in here though. So if we look at this, we can go in scripting and see what that looks like. So yeah, so we got this use rotation X, use rotation Y, and use rotation Z. So I think what we'll do is we'll add another field called up axis. We'll just call this use rotation equals prop predict. And I'm not seeing me using this too much. Probably would be good to just have this be required. So use rotation And we'll just add an assertion in to make sure that we use this going forward. Use rotation in predict. And let's see, point at. I kind of like, there's so many properties on things. I like making these functions where you're just sort of forced to check all of the boxes. And then, you know, you, let's see here. So if, let's see, then you're forced when you're writing this code to like make sure that you're being intentional about all of the settings that you're setting. And usually it's pretty obvious, you know, it's not like, oh, I know, whenever I make one of these, I'm going to know whether or not I want it to use rotation or not. It's not something I have to wonder about or I really want a default for. Okay, so that takes care of that. Now I think there was another place where I'm calling point at, so I got to make sure. Let's see here. Axis. And this is going to be, I need to get rid of this, but for now, user rotation is going to be false. Because that's what it was, that's what the default was before. This is an old functionality that I'm not using anymore there. Okay. All right, so now, let's see here. We still have our original layout for comparison open here. I hope I'm not gonna discover in an awkward way why that I was disallowing just make it. Why wasn't this allowed? I mean, it doesn't. Property. Yeah, that's strange. Okay, whatever. Let me just do a little cleanup here. Props, keys. Whoops. People watching. Oh, there's an error. Cert. Okay, yeah, so I just didn't actually add the user rotation in. So now we've got to add that in. So that was the child of, and wait, no. Yeah, child of. Oh, wait a second. Was I was defaulting other things there. I can default to that. That's reasonable. Child of. Oh, okay. Look at this. I was thinking of something else. I added that to point at. Okay, I wasn't tracking what I was doing. Yeah, okay. I wasn't paying attention to what I was doing. Yeah, track 2 does not have user rotation. That's silly. Okay, so it's the track 2. Track 2. And oh, it's not track 2. It's child of. Yeah, jeez, that's why I was getting. I have point at, track 2, and child of. It's child of, not point at. Child of. Child of. Okay. Child of. We can propdict.get use rotation and default that to false. That's fine. Okay, so, but we still now want to add use equals true for this guy, because the whole point of it is we're trying to get the camera to point, so we need to use rotation, right? Okay, let's clear out the logs, make sure that we're ready to go here. Okay, here we go. Here's one of my favorite songs, and we got another error of some kind. Yeah, this should not be object, it should be target. Child of. Oh, geez, now I'm now I've goofed this up too. Oh man. All right, I need to just take a step back here. Okay. So this is my point at that is goofed up. So point at. Where am I doing a point at? I was confused in multiple spots. So cam parent is going to be a track 2 and that has a target, not best. So that is target. Let's get rid of this point at nonsense. Okay. We're close now. We have to be close. Oh my gosh. It's one of those days. Okay, but we didn't have any errors. Okay, let's compare here. So we've got camera should have a child of constraint on it with everything activated. Track to cam parent. That looks good. Cam parent as a target. Oh, okay. The cam parent target didn't get set. Cam parent. The cam parent target should be camera. Wait, no. Oh, I see what happened. This got. This needs to come after. Oh my gosh. Okay. So target first, then the parent, because we're pointing at this, so that has to, yeah. Okay. And we should have gotten an error. Let's see here. Let's actually just revert that change, because that should make an error that I can debug easier than it did, because cam target doesn't exist yet when we run this track 2. So let's get that track 2 to throw an error. So this needs to be get object by name. If this is none, that should throw an error. So test equals this test. If test is none, raise key error. And target. Not getting quite as far as I wanted, but yeah, we're getting a lot of nice improvements here. So now if we switch our cam parent, let's come after target. Okay, so we got a question in the chat. BRSP says, where do I start from to get my 3D simple game done? Okay, so I don't, I guess I'd probably need more information to know, like, if you're using a particular engine or toolkit or something like that. My advice would be to find a well-documented engine, probably something like Unity or Godot. Make a simple project, follow some tutorials, try to keep it well defined and small to start, and kind of go through the project start to end, but something very small in scope. This isn't a simple project. It's kind of an ongoing, rambling, long project. I have a game as well that started off maybe kind of simple, but got more complicated over time. And I think if the goal is to finish something, it should be well defined, small, and you should kind of hold yourself to your plan. But using tools that have good documentation, commonly used engines, things like that, would help you a lot in that process. Okay, we're getting a lot closer. So we've got the camera. The camera seems to be aimed correctly now, or like, I think the parenting is done correctly, but we're missing some rotation somewhere. Okay, so this is, yeah, we just have the wrong rotation here on the camera. Whoops. Should be, yeah. Okay, see, now we've got the same thing. So let's just actually fix that. Pitch roll. Yeah, this actually needs to be third one because it's roll. Duh. We can start looking at the lighting here once we've got the layout, rest of the layout right. Ah, that's still not it. Oh, I know what's going on. This should not be radians, it should just be 30, because the idea with that HDR format is it matches up with the game engine that I'm using, and wow, that's still not right. What happened? Now that's concerning. HPR. Do I have... Is the camera update overriding that? Oh, that's strange. That is a little concerning. But we'll just swap this around, see if we can... Oh, that's right. The camera, it's roll around the z-axis, which is the same thing as heading. So it's, oh my gosh. All right. Okay. Yeah, there we go. Okay. So now we've got the same layout as our example. Dast we check and see if the sunlight is coming in from the same direction. Yeah. Let's turn this off. So we basically have got the same thing here except without the lower light. And that should be really easy to do. So let's do that now. Okay. This planet. See what strength I have this. I have that at 5. Math radians. I'm just copying over the angle, which, you know, the idea is here is we're flying, you know, over some planet that is taking up a 20-degree view angle in the sky. I don't, you know, probably sunlight isn't the best way to do this, but whatever. It looks pretty good. Looks pretty good, so we're gonna go with it. Put the color in here while we're at it. Planet color. I think these are called energy because I think that field used to be called energy in Blender. Angle constant. Okay. And then trans equals constant planet. Trans. And this is going to be just a simple matter of copying as well. So the idea here is that this planet light is pointing in the opposite direction as the sunlight, so it's like the sun light bouncing off of the planet. Again, the position here doesn't matter for a sunlight. Now, this is a little bit tricky. So basically, we're going to be switching a couple of these around. So the X rotation is going to be 190. That's the pitch. So now, and then heading is going to be 0. So that leaves yaw to be -10. Okay. And actually, let's just make these. This should all be lists, not tuples. Annoying as that is. Okay. This is all just kind of configuration nonsense, so it doesn't have a nice type. And am I using cam pause? Really? I guess. Okay. I think we're getting really close. Here we go. Yeah. Okay, let's turn real stars back on now, and we should have pretty much the same thing. So let me do that. And then I think we'll probably call it good for today. Unless a ton more people suddenly jumped in here. Yeah. Let's see. How does that look? Yeah. That's definitely the same. Cool. And we've got very similar lighting on things. I think all of these differences that we're seeing here are just due to the render configuration. Like if I take this to, let's see what I have here, 64 and 16, 64. Yeah, because I'm seeing a little bit more. Yeah, a little bit more of these panel details over here. Yeah, that looks pretty much identical. So now what's going to be kind of fun, and I think it's kind of interesting, and I'm trying to practice going through the process, so I'm just going to do it quick, is there's a couple, oh yeah, there's the star strength thing. So there's a couple other changes that, you know, eventually I want to make automatically, but I'm not going to do that right now. So we've got the fall off. Is it? Let's see here. Brightness fall off on the stars. We can make that 1 and that like more of them appear. And scale, let's see here. Scale FOV. Like, yeah. So we can get more stars like that. It's interesting. Seeing some different things going on there, but that's okay. Oh, that actually might just be, I'm looking at the original blend file on a different monitor. That might be part of some of the differences, is just the resolution. Yeah, that looks the same now. Okay, so there's that. And then what's really going to take this to the next level is some of the compositing stuff. So I'll just show you what that looks like, because it's really cool. So if we go into compositing, and actually let me just render this out. It shouldn't take long at all. Let's see, do I have the right? Just double this. Higher resolution render. Okay, so what we can do is we can add a couple things here. So that sort of help things look somewhat more realistic. So we can add a lens distortion. Just kind of starting to learn about some of this stuff. So we can add a lens distortion, and Yeah, so we can add lens distortion. And that gives us like a little bit of, it should give us a little bit of chromatic aberration. I can't really see it right now, actually. Here, let me, I should have a rendered view here. Let me just run this again. It's probably the quickest way to get it. And then we can also add a let's see here, texture and mix. So and then over here, we can make this be a noise. And then if we lower this factor way down, we get a nice kind of like film grain. And there's probably, whoops, this is a little, we can actually close. There's probably, well, there's definitely a nicer ways to do this, but, and you get this nice, it doesn't look perfectly smooth, you know. And I think like depending on your mode, and you could probably threshold this differently as well, like with a mix, and yeah, that looks pretty good. You know, it just kind of doesn't, keeps things, yeah, okay. And here you can see the chromatic aberration from the lens. I can't fit everything on my monitor here at the same time, but you know, like here's what actually just, there's a way to mute. There's a way to mute nodes. I need to figure that out. But yeah, so something like that, you know, a little bit of noise mixed in. We could probably take this up to where we start actually seeing it, and back it off a bit from there. Yeah, something like this. Yeah, and it's denoising the background. We'll add in. The other thing too is I have smoothing turned off, just because that takes a while to load when we're sort of interactively working with these things. But with smoothing turned on, you wouldn't see those extra polygons on the brown parts, like the drives. But yeah, see, I think this looks really good. I mean, maybe less noise. But like when you zoom out and look at it, you get a little bit of texture in there. You see a little bit of yeah, it's probably like ways to kind of squeeze that noise down a little bit. But yeah, and this, you know, I don't have materials on this yet. This is just kind of a rough object. Not a rough object, but it's a sort of a bare object. And there's also additional details I need to add to, but I think I'm pretty pleased with the render quality and just the general feel of this at this point. It's looking like I want it to look. So very exciting stuff. All right. Well, thanks everyone for watching. We made it through the scene layout stuff. So I'll be back probably sometime in the next few days for some more 3D modeling, maybe get back into some game dev stuff too at some point. But thanks everybody who watched for hanging out, and hope you're encouraged to work on some of your own creative projects, maybe over lunch break, and have a good rest of your day.